our objectives for today are going to be to find the sine, cosine, and tangent of an acute angle. Okay, so these three words, sine, cosine, and tangent, we're going to talk about those, but acute angle, we should really know what that one means. Again, we should remember that an acute angle is going to be less than 90 degrees. Okay, and so pretty simple. Okay, and we're going to use these particular trig ratios to find side lengths in right triangles and to solve real-world problems. Okay, so the vocabulary that we will go through, again, here is what a trig ratio actually is, what the sine is, the cosine, and the tangent, okay? And each of those three words, they are just a trig ratio, all right? So let's just take a quick look, almost a little background on some of these things, okay? So by the angle-angle similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with that same acute angle measure, right? Because since one of the angles is already 90, okay, and if the other angle or one of the other acute angles matches, well, there's only so many degrees in a triangle. There's only 180, so the other one actually has to be the same as well. And so in this particular example, triangle ABC. So if we look at ABC, the bigger triangle here, okay, so the bigger triangle, okay, is similar to triangle DEF, which again obviously is going to be right here. It's the smallest triangle, and that's going to be similar to triangle XYZ, which is kind of that medium-sized triangle. Okay. Now again, these are different sizes, but they're the same shape. They have all of the same angle measurements. Okay. Now because these are similar, a few things actually must be true here. Okay. So the next thing they do is they give us these three ratios that they say they're all equal to each other. Okay, and so what I'm going to do is just do a little bit of erasing here. Okay, and again, it says that the ratio of BC to AC, right, which is BC to AC, is going to be equal to the ratio of EF to DF. Okay, so I'll write EF to DF. Okay, and obviously we're talking about this side to this side. Okay, and then finally that's supposed to be equivalent to YZ over XZ. Okay, which is again YZ is here, XZ is here. Right, so notice that again that triangle is sort of reflected around there a little bit, but we're basically comparing here in all of these, we're comparing the shorter leg to the hypotenuse, okay? And again, all of these are supposed to have the same ratio, right? And that kind of brings us to our next important part here, okay? So you're going to want to look at this table more than once, okay? It's pretty important, and as you can see, there's a lot of information on here, right? So we have all the trig ratios here, right? So we see that we have sine, we have cosine, and we have tangent, okay? Now, when we look at a right triangle, we have to be able to identify the vertex, the opposite side, the adjacent side, and the hypotenuse, okay? And so let's just kind of look at one simple example here on the right-hand side. I'm just going to maybe just call this part, so I'll just name this ABC, okay? And let's just say we're really interested in angle C. Okay, so I'm just going to maybe mark this in red here a little bit. Okay, we have to understand that the opposite side to angle C is the sides that don't share that common vertex of C. So if I'm asking about the opposite side for C, I can't choose BC because this vertex is part of C, right? This side right here. Okay, it also connects to that vertex of C, so that's not the opposite side. The opposite side to C is BA. Okay, so we really have to understand that that's what that means by the opposite side. Okay, so I'm just going to maybe say this is opposite to C. Okay, now we also have to understand here, I should really make this a right triangle. Okay, we also have to understand here that the side that's adjacent to C, adjacent is basically meaning joined or next to. Okay, now we're going to refer to the adjacent side to C as this side right here. Okay, the adjacent side is always going to be one of the legs of the right triangle, so it's one of the sides that actually forms the right angle with the other leg. Okay, and the hypotenuse is just going to be the side that connects the legs. All right, let's go back to adjacent for just a second. So this side, AC, is adjacent to C. Okay, and the hypotenuse, you know, this side right here, I'm just going to kind of outline in black again. I'm just going to say the hypotenuse connects the legs. Okay, so hopefully that helps out a little bit with these words, opposite and adjacent and hypotenuse, and we'll get lots of practice with this today. So again, this is something that you should definitely write down in your notes. Okay, I'm going to go ahead and erase this now and explain just a couple more things. Okay, now it tells us this really confusing, you know, and really long language. It tells us, you know, sine, cosine, and tangent, what this actually means. Okay, so I'm going to give you something that's a little bit easier. Okay, I want you to call this so. Spell it like this: so ka toa. Okay, now SOHCAHTOA. All right, this is something I'm going to say a million times in class. Now the S here stands for sine. Okay, so the S again stands for sine. Right, the sine is going to be the opposite divided by the adjacent. Okay, now notice over here, the sine is, excuse me, this is the opposite over the hypotenuse. Okay, so opposite over hypotenuse. So when you look at the sine on both of these, when you're asking about the sine of a certain vertex, it's the opposite leg over the hypotenuse. The sine of B is again the opposite over the hypotenuse. So you can look at your diagram here, okay, and we see that the sine of A, well, the opposite of A is this little a right here, and the hypotenuse is C, that connects the leg, so A over C is what we have. Okay, now for cosine, the next one we're talking about is cosine. This is going to be a little bit different, right? This is going to be adjacent over hypotenuse. Okay, so when we look back at the cosine over here, again, on both of these cosine ratios, whether we're looking for the cosine of A or the cosine of B, we take the adjacent leg. Okay, so again, that's going to be connected to the specific vertex that we're talking about. So the side that's adjacent to A is going to be B, and the hypotenuse is still C. So B over C is what we get. Okay, and we have, again, the cosine of B. Well, if we look at B right here, the side that's adjacent to B, again, can't be the hypotenuse. The adjacent leg is A. Okay, and the hypotenuse is still C, so A over C is what we get. Okay, and you may have guessed at this point, TOA, the T stands for tangent. Okay, and tangent, we're talking about the opposite leg over the adjacent leg. So again, notice down here, okay, we have opposite over adjacent, okay, and opposite over adjacent. So the tangent of A, so if we look at A, the opposite side is the little a, and the adjacent leg is the B, so A over B. Okay, now if we're asking for the tangent of B, the opposite of B is the smaller b, and the adjacent leg is A. So SOHCAHTOA, that's going to be how we remember this. Another way that we can remember this, okay, I'll maybe make a couple lines here. We can, some of you guys might like this, sine, all right, sine, cosine, tangent, and we just have to remember that this is, oh, heck, another hour of algebra. Okay, so if you can remember that little mnemonic device there, or one of those two, we're going to be in great shape. Okay, but we'll get through lots of examples here, so you guys feel nice and comfortable with these trig functions.